Hi there! In today's video, we are going to discuss the powerful capabilities of Teledyne LeCroy's LPDDR5 and LPDDR5X Debug Toolkit. For this demo, our device under test is an LPDDR5 device running at 5500 megabits per second. We're using the WaveMaster 8000 HD oscilloscope to capture and analyze these high-speed signals. To access the signals with high signal fidelity, we have attached a DRAM interposer which provides high-quality connections to various signal lines. For probing, we have connected our DH series high-frequency differential probes. Here, we're probing the system clock, write clock, read strobe, and data lines. Now, let's explore the LPDDR5 Debug Toolkit and its key features. The workflow is intuitive, moving from left to right in the user interface. We start by configuring the speed grade, clock to write clock ratio, and the device's operation mode. Next, select the right sources for all the signals in one of the views and set the voltage thresholds and preamble settings for each signal. These are crucial for accurate measurements and for distinguishing between read and write bursts. Once everything's set, we enable DDR debug and activate one of the views with analysis type. In this example, I have selected view 1 and read as my analysis type. There are various methods of read-write separation. In case of LPDDR5 or LPDDR5X signals, the toolkit identifies read and write bursts by analyzing several parameters, including the state of RDQS signal. An active RDQS signal typically indicates a read burst. The decoder table lists the decoded burst types, their time in the acquisition, information about the device operating mode, and the bit lengths for each burst. In addition, it also applies an overlay for different parts of the signal with relevant information. To zoom in on a burst of interest, just click on any row in the table and it will take you right to the packet location. Here, the write clock or WCK is active, and we see activity on both DQ and RDQS signals. The presence of an active RDQS signal tells us this is a read burst. We notice a static preamble followed by a toggle preamble, then the payload, and finally a postamble indicated on both WCK and RDQS signals. The overlays make it easy to identify each part of the signal. Now, let's make a quick measurement and generate an eye diagram for our read burst. As you can see, all these processes are seamlessly handled by the LPDDR5 Debug Toolkit. That's a quick look at the LPDDR5 Debug Toolkit in action. Reach out to us if you have any questions or would like to get a demonstration from a local sales representative. Thank you.